Hi everyone. Now let's see the next busy waiting solution in synchronization mechanism technique. So strict alternation approach, or it is also called turn variable. It is the fourth busy waiting solution in synchronization mechanism technique. Before this, I have already discussed the one is lock variable, the other one is test set lock, and the third one is disabling interrupt. Okay, so it is a software mechanism, so it is very important to be noted here. It is a software mechanism means it is portable. So the secondary requirement, which is architectural neutrality, says that the solution of synchronization mechanism technique can run on any hardware or any platform. So this solution can run on any hardware or any platform. Why? Because it is a software mechanism, and software mechanism is implemented by a programmer or user. So it is a software mechanism implemented at user mode. Okay, and the next point is it is a two process solution. So this point is very important for turn variable. Only two process can enter the critical section. Only two process can use the shared resources by alternating approach. Okay, by alternation approach. So what I mean to say, let's say we have two process P0 and process P1. So process P0 and process P1 is eligible for this busy waiting solution, or you can call it as process Pi or process Pj. Okay, so only two process can be eligible for this busy waiting solution. That's why it is called two process solution. And turn variable only takes two values. So here we are using a special kind of variable, which is turn variable. And in turn variable, it takes only two values, 0 and 1. 0 says that process P0 enter the critical section, or process Pi can enter the critical section. Turn value 1 says that process P1 can enter the critical section. Process P1 enter the critical section. So it is very important that if you remember the lock variable, in lock variable we also use two values. One is 0 and other is 1. But 0 says that critical section is vacant and 1 says that critical section is occupied. But here the difference is 0 says that process first can enter the critical section, and 1 says that process second can enter the critical section. So that is the major difference between lock variable and turn variable. And because of this property, or because of this turn variable, the strict alternation approach or turn variable has got some more advantage compared to the variable which I have discussed in earlier video. Okay, that is lock variable. Okay, now here turn variable is a global variable, so it is very important. Turn variable is global variable, means turn variable can be used by the both processes, process P1 and process P0 and process P1, and the particular code which are implemented in process P0 and process P1 are different. In P1, this is critical section. Okay, here it is also critical section, and this line is the entry section, and this line is the exit section. Similarly, in process P1, this is entry section and this is exit section, and before and after the entry and exit section there is non-critical section. Okay, non-critical section means no shared resources are available here, so only P1 process can have the right to execute the non-critical section. Similarly, before and after this critical section in P0 there is non-critical section. Okay, so non-critical section is a common code which are implemented by the individual process. So let's talk the P0 code first. So here it says that in the entry section, P0 check whether the value of turn variable is not equal to 0 or not. Okay, whether turn is not equal to 0. Initially the value of turn is not fixed, means those process who first enter the critical section can decide whether the turn variable will be 0 or 1. So here if turn variable is not equal to 0, then process P0 is falling in infinite loop and it does not enter the critical section. Okay, and similarly for process P1, if turn is not equal to 1, if turn value is not equal to 1, then process P1 is falling in infinite loop. And if turn value is 0, then this process can enter the critical section and it will use the critical section or shared resources. And after using the critical section, when it leaves the critical section, it will make the turn variable as 1. Okay, so that process P1 can enter the critical section. So here one important thing is, if we talk about the requirement of synchronization mechanism technique, so there are 4 requirements. 2 are primary and 2 are secondary. One is mutual exclusion. So definitely here mutual exclusion is provided because of this code. So in this code, if turn is equal to 0, then process P0 can enter the critical section, and if turn is equal to 1, then process P0 cannot enter the critical section, process P1 can enter the critical section. Similarly here, if turn is equal to 1, then process P1 can enter the critical section. If turn is equal to 0, then process P1 cannot enter the critical section. So here mutual exclusion is definitely guaranteed. Now the next is progress. So you can consider turn variable as a key. Okay, you can consider them as a key, and this key is given to any one process, so that the process can use this critical section and give them back the key to the other process. But what happens if the key is given to some process and those process does not interest to given them back to the other process? So in that case, or in that scenario, the progress will not be guaranteed. So here progress is not guaranteed. Why? Because if the value of turn variable is 0 and process P0 does not interested to enter the critical section, so it will not enter the critical section, and based on this, process P1 is also not enter the critical section due to the turn variable. So definitely here progress is not guaranteed. And what about the secondary requirement? Secondary requirement is, one is secondary requirement is bounded waiting, and the other is architectural neutrality. So bounded waiting here bounded waiting means starvation, long waiting. So here turn variable is supposed to provide the property that every process should be bounded by some particular mean or some particular key aspects. So here turn is definitely guaranteed, turn is definitely bounded by the each process. So definitely here bounded waiting is also provided. You can say that no process could be waiting longer due to the other process. Why? Because if turn value is equal to 0, process P0 can enter it. If turn value is equal to 1, process P1 can enter it. So, okay, so turn variable is the main bounding criteria which bounds the two processes, process P0 and process P1. So bounded waiting is provided, and it is a software mechanism. So it is implemented by a programmer or user. So definitely it can run on any platform or any hardware. So it provides architectural neutrality. Okay, so this solution, strict alternation approach or turn variable, provides 3 requirements. The 2 primary requirements are the one primary requirement is provided, which is mutual exclusion, and the 2 secondary requirement is provided. One is bounded waiting and the other is architectural neutrality. Only the drawback here is it does not provide progress. Okay, so in the next video we will see some difference between lock variable and turn variable.